Well, hello everybody. Welcome to Thursday. Today we're going to be learning about the point-slope form of a linear function, which is another form of the linear function that we're going to take and write in slope-intercept form. So let's go over to our KWL chart and get started for today. And we're going to start off with what we already know about the two types of linear functions we've already studied. So we see here that we have the linear function in slope-intercept form, which is modeled as y equals mx plus b, and that models a single event. So we had the example of Christopher, who has $80 in his bank account and is saving $25 per month, and we want to write an equation to model Christopher's savings. So using the y equals mx plus b model, we write y equals 25x plus 80, because 25 is the rate of change, how much it's changing per month, and $80 is what he started with. Then we also have the linear function in standard form, which is the ax plus by equals c. And this models more than one quantity or event. So the example would be your parents are planning to bring a group of yours and their friends to the zoo. They have $300 to spend. Children under 10 cost $5 and adults cost $10. Write an equation that can be used to model their possibilities. So what we had to do here, since we have two simultaneous events going on at the same time, is we had to assign a value to each of our variables. So we let x equal the children and y equal the adults. So using the ax plus by equals c model, we put the rate of change of 5 with the children, which is 5x, and then the rate of change of 10 with the adults, which is the 10y, and all that together equals $300. So today, what I wonder is, how can I model 2 points or moments in time, or 1 point or moment in time, and the slope? So the way we're going to do this is using the linear function in point-slope form, and that is written as y minus y1 equals m times x minus x1. That is the model for the point-slope form of a linear function. So let's look at our example here to see how this would be used. Tyler went on a hot air balloon ride. He tracked the altitude as the ride began. After 6 minutes, they were 62 meters in the air. When he checked at 15 minutes, they were 146 meters in the air. Write an equation that models the altitude of the hot air balloon for any period of time. So what we are going to do is we're going to take these 2 points or 2 moments in time, put them in the linear function point-slope form model, and then change that model into the slope-intercept form, so it will be in the form of an equation that we can use to find the altitude of a hot air balloon at any time. So we're going to do the same thing that we did before, is we're going to assign values and meaning to our variables. So we're going to let x equal the minutes, and y will equal the altitude, which is going to be in meters. So since we have here 2 points or 2 moments in time, my first moment in time is 6 minutes, represented by x, and is going to be the x of the ordered pair, and 62 meters. And then my next moment in time is 15 minutes and 146 meters. So I'm using the ordered pairs to represent this situation. All right, so if we look here at our ordered pairs, the point-slope model is y minus y1 equals m times x minus x1. All right, so what we need to do is we need to identify each of these as y1, y2, x1, and x2. Now, since you're dealing with a linear function and constant rate of change, it really doesn't matter which one you identify as y1 and y2 or x1 and x2, because it's all going to come out the same in the end. All right, So the first step is going to be to find the slope. So slope, which is m, equals y2 minus y1 over x2 minus x1. So here my y2 is 146. My y1 is 62. My x2 is 15. And my x1 is 6. So 146 minus 62 is 84. 15 minus 6 is 9. Now, both of these numbers here, 84 and 9, can be further simplified by the number 3. So that's going to leave me with 28 thirds. So my slope here, my m value is going to be 28 thirds. Now we're simply going to plug in x1, which is 6. And then my y1 value is 62. So first thing we did is we found the slope. Now we're going to distribute the slope. So we have 28 thirds times 6. All right. I'm going to cross multiply these away since 3 is a multiple of 6. So, or a factor of 6. So that's going to leave me with a 1 down there and a 2 up here. When I multiply across, 28 times 2 is 56. So I found the slope. I distribute the slope. Now I'm going to add or subtract y1. So the y1 is here. Because negative 56 plus 62 is a positive 6. So now I have an equation in slope-intercept form, y equals 28 thirds x plus 6, that I can use to describe the altitude of the hot air balloon at any period of time. So let's look at how we can use this then. If I have y equals 28 thirds x plus 6, and I want to find out what is the altitude at 30 minutes. So again, if I come over here and do 28 thirds times 30, again, I can cross multiply that 3 away, and I'm left with 28 times 10, which equals 280. So y is going to equal 280 plus 6. So y equals 286. So that means that after 30 minutes, this hot air balloon will be 286 meters in the air. Okay, so the equation that we'll put here is y equals 28 thirds x plus 6. That is the equation that we can write that models the altitude of the hot air balloon for any period of time. Okay, so let's look. I'm going to show you 2 other ways that you're going to be using the point slope form of a linear function and how to turn that into slope intercept form. So if we look here at this example, it says to find the equation of a line with a slope of 4 that passes through the point 2, 3. So we would begin with our point slope model of y minus y1 equals m times x minus x1. And in a situation like this, I'm just going to label x1 and y1, and I'm going to substitute all these values into their proper place in this point slope model. So y minus my y1 is 3 equals m, which is my slope. So 4 times x minus x1, which is the 2. So same thing that I did before, I'm just going to distribute the slope. And then I will add or subtract the y1 value. So now I have solved for y, so y equals 4x minus 5. Now the other way you're going to see this, which this is what you're going to be doing for today, is you're going to change each of these from point-slope form into slope-intercept form. And again, the reason that we want to do this is because when we change it into slope-intercept form, it gives us the slope, it gives us the y-intercept. We can then graph the line with that information. Also, you can use it to model and predict different changes at different moments in time, because functions are all about modeling and predicting change. All right. So there's the first one. It's the second one. And the last one. So that's how you would change those into slope-intercept form. Just distribute and solve for y, or just distribute and add or subtract the y1, and you'll still be solving for y. So what have we learned today? We have learned how I can Okay, so that's what we've learned today, is you can change an equation in point-slope form into slope-intercept form to model and predict change. And the way that we do this is we find the slope if necessary. Then we distribute the slope. And then we solve for y by adding or subtracting y1. All right, so that's what we learned today. All righty, so what you've got for today is another maze sheet, as every week in math is an amazing week in math, so we'll make this another amazing week with the maze. And all you're doing is changing these in point-slope form to slope-intercept form, like I just got done showing you. All right. Once you're done, of course, upload it to Canvas. And then tomorrow we're going to work some more on these with 2 points and some different scenarios. All right. So I will be on Google Meet, my normal hours, if you have any questions. And that's all for today. Have a great Thursday.